All right, Friday we talked about, or not Friday, Tuesday. Hope everybody had a good Thanksgiving break. Take too much, of course we all do. Everybody enjoyed the holidays and the time to get off and the Michigan win over the weekend. And that's right. There we go. Yeah, I sat there and I had a feeling that possibly could happen because when you're talking about fifth year seniors, people that have been in that game before, compared to freshmen that are coming in to play. You're looking at 22, 23-year-olds going up against 18 and 19-year-olds. That's never been in that type of game before, in that type of atmosphere. There's a definite advantage, especially when you're away. If it was at Ohio State, they would have a better chance. But hey, it is what it is. Congratulations to the Wolverines. It was a good weekend for the Hardballs, wasn't it? Yeah. Bad weekend for Ohio sports, wasn't it? Browns. I'm glad I went to that. Anyways, on Tuesday, we worked with the idea of graphing of asymptotes and looking at rational expressions. Solutions were provided for you. Questions you have about any of the types of problems in regards to vertical asymptotes, horizontal asymptotes? Again, please do keep up with the material. Okay, this is the last section that we will go through in regards to this chapter, chapter 3. We're going to start working with what's called quadratic inequalities. We've solved quadratic equations, and we have different methods of madness in solving quadratic equations, but we've not solved quadratic inequalities. We'll spend today, tomorrow, on sort of a worksheet that combines everything together. Wednesday and Thursday looks like will be a quiz. Then we'll steer ourselves towards a chapter test at the beginning of next week. We don't have much time left here within your class. Our last 2 weeks, we will go over the idea of logarithms and working through logarithms. If I give you an equation, 3x plus 4 is equal to 7, and I ask you to solve that and graph that. I'll get some numbers up here. 0, 1, 2, 3, 4, 5, 6. Get some numbers on your number line. I want you to solve that equation. 3x plus 4 is equal to 7, and graph it. Cole, what do we get? X equals what? X equals 1. X equals a value of 1. We can subtract our 4 from both sides. So we have 3x is equal to 3, and divide by 3, x is equal to a value of 1. That is our solution. That is the value of x that makes our equation true. If I would take x, a value of 1, and sub it in for my value of x, I would have 3 times 1 plus 4. I get 3 plus 4, which is the value of 7. If we would take a look at graphing this, what would the graph of x equals 1 look like? Lexi, what would the graph x equals 1 look like? What do you think? A dot on 1. This is where our x value is equal to a value of 1. We have a dot on 1. What regions does the equality point separate our number line into? We have this entire number line over here. We have this entire number line. This is where x is equal to a value of 1. I now have two regions. A region to the left and region to the right. What could we say is true about all the numbers to the right of 1? What can we say is true? Yeah, these are all values of x that are greater than the value of 1. And if I go to the left, we have a little less than 1. So these are all the values of x that are less than the value of 1. So this equality point separates our number line into two regions. One where we're greater than the value of 1, one where we're less than the value of 1. So equality separates our number line into less than and greater than regions. And this is a key idea to remember. Equality separates our number lines into less than and greater than regions. And there's an old school property of mathematics. It's called the trichotomy. The trichotomy property. I always remember going back into learning properties of mathematics when I was in 6th grade or 7th grade or 8th grade. And you had the commutative property, you had the associative property, you had the distributive property, all these little properties we learned. Well, I remember at one point there was a trichotomy property that says basically two numbers will be equal to each other, or one will be greater than the other one, or one will be smaller than the other one. And I just went, duh, yeah, no, it's always going to be that way. Well, that's sort of the idea of what we have here. We have x is equal to a value of 1. All these values are greater than the value of 1 to the right, and all these values are less than the value of 1 to the left of us. This is a key phrase to remember. Equality will separate our number line into less than and greater than regions. Because now what I want you to solve want us to solve is the problem x squared plus 3 times x, or x minus x plus 3 times x minus 2 is less than a value of 0. Well, what we have solved so far, when we were solving quadratic equations, we would factor a quadratic equation down into two factors and set each one of these factors equal to 0. We were able to solve these equations using our multiplication property of 0. We were able to solve this equation. But what we want to do now is we want to be able to solve for the values of x that are smaller than the value of 0 here. Well, that's where this first phrase will be very helpful. Equality will separate our number line into less than and greater than regions. Well, the question is, what makes x plus 3, x minus 2 equal to a value 0. Isaac, what are our values? X equals -3 and x equals a value 2. These are the values that make our equation equal to a value of 0. These are the values that give us equality to 0. Equality separates our number line into less than and greater than regions. So if we take a look at what we did up top here, we first graphed x equals 1. That is where we had equality. So if we take a look at our number line, at x equals -3, this is where we have equality equal to 0. At x equal to 2, this is where we have equal to 0. This gives us our division of our number line into 3 different regions. And using the statement of what we had up above, this equality will separate our number line into less than and greater than regions. So these regions that we are separated into makes us less than or greater than the value 0. Well, how do we determine which one makes us less than or greater than the value 0? Well, we do this by trial and error. We pick a number in a region. And it does not matter which number we pick. If we go to the left here, we'll just look at the value of -4. If we substitute -4 into our problem here, we have -4 plus 3, which gives us -1. If I put -4 into our second factor, we have -4 minus 2, which gives us -6. We have -1 times -6. Kylie, what does this give us? Positive or negative? Positive 6. Gives us positive 6. We multiply our numbers together, and we're going to go back to how we learned how to multiply integers. We multiply the numbers together. 1 and 6 gives us 6. But how did we determine if it was a positive or negative? Austin, how do we determine if it's positive or negative? How do we know it's positive 6? I have -1 times -6. Multiply 2 negatives together. So really, the 6 and the 1 didn't determine if this was positive or negative. What determined if it's positive or negative was our 2 negative signs. Our 2 negatives came down to a positive. Well, when we talk about positive numbers, are positive numbers less than the value of 0? No. Positive numbers are greater than the value of 0. Well, we're looking for the values that make us less than the value of 0. I come down to positive 6. That's not less than 0. So what I'm going to put in there is I'm going to put an F for, this is a false region. But now we're going to try to be a little bit more efficient to be able to determine if we have positive or negatives in a region. Because this 1 times 6 didn't matter, that's going to give me 6. The negative times negative gave us the positive value. So really, do we have to worry about how big the negative is or how big the positive is? No. I pick another value. 0 is the easiest one. If I put 0 in for x here, I have 0 plus 3. Mike, is it positive or negative? That is positive. If I have 0 minus 2, is that positive or negative? Negative. So we have a positive times a negative, which is a negative. Doesn't matter that this is positive 3 and negative 2. That's going to give me negative 6. Doesn't matter if it's negative 6, negative 8, negative 10. It's still going to be a negative value. If I have negative values, are they greater than the value 0 or less than the value 0? Less than. And that's what we want. So this is a true section. If I take a value, 3, 4, 5, does not matter, and plug it in, Emily, do I get positive or negative with the first one? Positive. If I put it in for the second one, do I get positive or negative? Positive. Take a positive times a positive, that gives us a positive. Are those values less than the value 0? No. So this is a false section. What we want is we want the true sections. Any one of these values that I put in here is going to make us less than a value 0. So if I'm looking to graph my true section, I want to graph this middle section. Okay, I have just less than the value of 0. If I have less than the value of 0, what's going to appear on our graph? Just less than.
So just less than.
Yeah. What's going to appear on my graph? Am I going to get solid dots or am I going to get hollow dots?
Hollow.
Hollow dots. That's correct. We're going to get open dots here. And we're going to shade in between. And then writing this in interval notation, x is a member of. Do we have brackets? Do we have parentheses? Brackets or parentheses? Parentheses. So we have parentheses, negative 3 to 2. We take a look at the next one. We have to take it one step further. We have x squared plus 3x minus 4 is greater than the value of 0. We need to first find out what makes us equal to 0. Once again, we're using that trichotomy property a little bit where we have equality. If I have equality points, I'm going to have less than and greater than regions. So I need to figure out what makes us equal to value 0. So the first thing we're going to have to do is factor this down. Jenna, what does this factor to? X plus 4 and x minus 1. Makes us equal to 0. So our two values that make us equal to 0, Jack, would be what? I'm sorry, what? 1 and negative 4. So I go to my number line. I always put little fences here. That's what makes us equal to a value of 0. Then I try values in each one of our regions. I go to the left of negative 4. I go in between negative 4 and 1. And I go to the right of 1. And see, do I have positive or do I have negative values here? Go ahead and plug in values. Do your pluses and minuses in each section. and check your solutions with somebody around you. Subbing in, looking at to the left of 4, Owen, what do we have? We sub in. Are we positive or negative? I'm sorry, positive. We have a negative, which gives us a positive. Is that greater than the value 0? Yeah. In between, what do we have? We have negative. We have a positive with the first one, but we have a negative with the second one. So we have negative there. So that is false. And if we go to the right, we have what? Positive and positive, which gives us positive. So it's a true section. So getting our solutions, we should have open dot going to the left, open dot going to the right. Once again, we need to get it in correct interval notation. So we have x the member of negative infinity to negative 4. Open, union, 1 to positive infinity, and beyond. Let's solve the next one. Okay, what makes it equal to 0 first? We need to factor it down. What makes it equal to 0? Draw your number lines in. Do your trials from each section. Amber, what makes this equal to 0?
Negative 5 and 2.
Now, I don't get too extravagant as I go along with these, with my number line. I get my key values down, but I'm not going to hash out all the values that I need in between. I get my 0 in there. And I can separate into my regions. Okay, if we go to our first region to the left of -5, Callie, what do we have, positive or negative? Positive. We have a negative and negative, which gives us positive. Are those values less than the value 0? No, so it's a false section. Between -5 and 2, what do we have? Negative. We have a negative value or a positive value here and a negative, which gives us negative. Is those values less than 0? Yeah. And to the right of 2? Positive, positive, which gives us positive, and that would be a false section. Now, looking at our graph, what we have to make sure we take a look at is our equality symbol. We are less than or equal to. So if I look at graphing this, Sean, what will we have if we graph this?
2 closed dots.
2 closed dots. So we have a closed dot and we have a closed dot in between those two. So if we take a look, Sean, what's going to go in our interval notation?
Bracket -5 to 2 bracket.
So we have brackets on both those ends, -5 to 2. But what happens if we have a rational expression? We have x minus 3 and x squared. If we take a look at our divisions, we can turn this into a multiplication problem by taking 1 over x squared and x minus 3. If we look at factors of each, the top and bottom, that gives us equal to 0. Now I know we cannot have a denominator that's equal to 0, but it gives us a division point that we will need. So we're looking at this x squared equal to 0 and x minus 3 equal to 0. It gives us a division point. I know our denominator cannot equal 0. That gives us an undefinedness. But it gives us a division point that we can work with here. So hopefully we can see that's x equals 0 and 3. Now if we take a look at our number line, once again, I know we can't equal this value, but it gives us a division point. That we have to work with. We have x squared on the bottom. Whenever I square a number, whether it's positive or negative, what are we going to come up with? Zach, what do we come up with? Whether it's positive or negative, if I square, what type of number are we going to get? It's going to be positive. So we're always going to get positive on the bottom. So we get this positive on the bottom. If I put our negative 1 in there, what we get, Justin? We get negative on top. So we have negative divided by a positive, which gives us negative. Okay, does that make us less than the value of 0 then? Yeah, so this is a true section. This is a true section. If we go between 0 and 3, if we go between 0 and 3, Sarah, what are we going to get on top? We're going to get a positive value or a negative value? Negative. If I put 1 in, 2 in, I have 1 minus 3, 2 minus 3, I'm going to get negative on top, but on the bottom I'm still going to get what? Positive. So we have negative divided by positive, which still gives us a negative quantity. Okay, which is a section that we want. If we go to the right of 3, Todd, what do we get? Positive divided by positive, which is a positive quantity, which is a false section. What we have here is we have less than or equal to. So when we have that equality in there, what we typically do, we put solid dots in. But we have a problem if we fill in with solid dot here, and fill in our true sections. Because this x squared is on the bottom. With this x squared on the bottom, we can't have a 0 on the bottom. So basically, we have to worry about this because we're including 0 in our solution. So what we have to do is we just have to hollow this out. Make it a hollow dot. Once again, we have two versions of a solution here. We can go from negative infinity to 0, union 0 to 3. Whoopsie. Or we would have a bracket at the 3. Or, once again, we can do this, negative infinity to 3, and then write in x cannot equal 0. That's the same problem. Let's take a look at the very last one here. Okay, factor your top, factor your bottom. Both of them should factor difference of perfect squares. What makes each one of them equal to 0? You should have 4 points, 4 values. Go to your number line. Place those 4 values on your number line. Should have values of 2, -2, 5, and -5. Your separation points. And then you just go through and you try each section. There is no shortcut way of doing this. You just have to go through. And once again, number sense and math sense. If I put in a value -6 and -6 plus 5, that's negative, 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 negative. That should give us a positive and a true section. And a lot of times, not always, when you start getting square terms in there, you'll double up side, or you'll get sides side by side, adjacent sides that are both true or both false. But if you talk about a typical problem, a lot of times it's going to alternate true, false, true, false, true, false. So we have positive, negative, 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 which is negative. This gives us false. So if I put 0 in, I get positive, negative, negative, which is positive. This is a true section. If I put a value of 3 in, you get positive, negative, positive, positive, which is negative, a false section. And we get positives with everything. Sorry, I'm rushing through it. We're just getting close to the end here. What you have to watch out for is your denominator. We can't make that denominator equal to 0. So we have solid dot on -5 going to the left. But I go between -2 and 2. We have to get hollow dots on both of those because it makes a denominator equal to 0. Then we have a solid dot and 5 to the right. So we have to watch our positive, our brackets or parentheses. Homework, I gave you a worksheet that's basically more practice in regards to your quadratic inequalities. This is the last of the material. Once again, tomorrow we will have sort of a combination worksheet, probably an in-class assignment. Yeah, in-class assignment. I love that. Wednesday will be a review day, Thursday will be a quiz over this material.